Okay, part 2 of lesson 5.6. So let's start out with this type of a problem. So this subtraction right here allows me to write this as just a single log. So I'm going to write this as log of 5x plus 1 over 2x minus 3, because subtraction means division. That equals 2. Then I could say, okay, let's use my base rule. So I've got a base of 10. So 10 squared equals this. So I'm using those log rules again. So 10 squared equals 5x plus 1 over 2x minus 3. Okay, so then this is the same thing as 100. And I'm going to take both sides times 2x minus 3 to get rid of this. So this is really 100 times 2x minus 3. So that's 200x minus 300 equals 5x plus 1. So then I'm going to minus my 5x, so 195x equals, add my 300, so equals 301. So that means x equals 301 divided by 195, which is kind of messy. But as a decimal, that is 301 divided by 195 gives me about 1.54. So that's my answer for that one. So I was able to get rid of that log pretty quickly, which is nice. All right, so then number 6. So same thing, I'm gonna try to combine these. So let's see, let's go ahead and let's subtract this one first, because this doesn't have a log. So let's subtract this one over to here. So I have all my logs on one side. Then I can combine and get rid of as needed. So, okay, so that gives me log of x plus 3 plus log of x minus 3 minus log of x squared plus 5 equals that negative 2. All right, so if I put these together, these are being multiplied together because of the addition, and then we're going to divide by this one. So this is log of x plus 3, x minus 3, over x squared plus 5 equals negative 2. All right, so then let's use, I'm going to try to do two things at once here. One, I'm going to go ahead and use my log rules again and say this is really 10 to the negative second equals this stuff. But I'm also going to go ahead and simplify this, because x plus 3 times x minus 3 is x squared minus 9. If you need to FOIL that out, that's fine. Okay, then I'm going to cross multiply. So let's start out with this though. So this is the same thing as 1 over 100 equals that x squared minus 9 over x squared plus 5. So now when I cross multiply, I've got that times that. So let's do this one first. So 100 x squared minus 900 equals x squared plus 5 times 1 is just x squared plus 5. Okay, then let's see, I'm going to subtract my x squared, so that gives me 99x squared. Add my 900, that equals 905. So x squared equals 905 divided by 99, which means x equals plus or minus the square root of 905 over 99. Okay. So now we need to think kind of outside the box here. If I take my square root, I've got two different answers here. I've got a positive and a negative. If I take a positive square root of 905 over 99, I'm not too concerned about that, because I think when I look back up here, I'm just trying to think about these plugged back in up here. So here, if I square that, it's fine, no big deal. This one, that minus 3, so this has to be at least bigger than 3, the square root of that. So let's look at that. 905 divided by 99, if I square root that, it has to be bigger than 3, which it is. barely, but it is. So this would still be positive, and that one would be positive. Now, if this were a negative, that's going to be a problem. So that one would be an extraneous solution. It says it's a solution, but when I plug it back in, it doesn't work. So that's not an answer. My answer really is just the square root of 905 over 99, which as a decimal was 3.02. Okay, so don't forget about those extraneous solutions. I don't want you to forget about plugging things back in up there. Okay, so this one, let's see. I'm gonna combine these, and then I'll show you what I'll do from there, because this is gonna actually make it a lot easier. Okay, so this would be the log of, because it's subtraction, that's division, so x minus 4 over 3x minus 10. And that equals the log of 1 over x. Well, that means because these are the same base, this equals this. So x minus 4 over 3x minus 10 equals 1 over x. Then I can solve from there. So let's just cross multiply. So x squared minus 4x equals 3x minus 10. Let's get everything, because this is a quadratic, let's get everything over to one side. So I'm going to minus 3x and add 10. Then let's factor if possible. And this one is factorable. If I use 2 times 5 is 10. If both of those are negative, when I add them, I get negative 7. So x equals 2, x equals 5. Now again, go back and check, because if I plug this one in right here, 2 minus 4 is negative 2. Can't do the log of a negative, so this one is an extraneous solution. This is my actual solution. If I take 5 and plug it in, that works. 5 there, that works. 5 there, that works. Okay. All right, so last one. This one is a lot more complicated. Okay. So you do have a problem in your homework like this, so I highly suggest you come back to this example. It will help a ton. So the first thing that I'm going to do is get this over here to this side, and then what I really want this to look like is a quadratic. And so I'm going to have to do some fixing. Sorry about that, I moved it. I'm going to get this over to this side, and then I want this to be a quadratic, and I'll show you how we can do that. So 3 to the x plus 9, 3 to the negative x minus 28 equals 0. So the first thing I'm going to do is I'm going to take this whole thing, really both sides, times 3 to the x power. And why would I do that? Well, if I took it times 3 to the x power, that means I have 2 of those in this first one, which means it's squared. So let's talk about that. This 3 is going to stay put. A 3 to the x times a 3 to the x is a 3 to the x squared, right? And then plus, if I take this times 3 to the x, you add the exponents, right? So an x plus a negative x is 0. So this is really 9 times 3 to the 0 power minus a 28 times a 3 to the x equals, this would be 0. Okay, now so I left it looking like this. Instead of saying 3 to the 2x, I left it like this to show you that, hey, this is a quadratic. So now this is really just 9. Anything to the 0 power is 1. So this is really just 9. So I'm going to put these in order. This is like if 3 to the x was x, this is like an x squared. This one is like an x. This one has none, right? So I'm going to reorder those. 3 to the x squared minus 28, 3 to the x plus 9 equals 0. So this is kind of like an x squared. This is an x. This is no x's. Okay, now I can factor this. Again, you really have to use your imagination. And to be honest, if you want to go over here and say, you know what, x for me, I'm going to call it u. So u for me equals 3 to the x power. And then just say this is 3u squared minus 28u plus 9. Then factoring it might be a little bit easier to kind of like visualize. So in my case, I'm going to do 3 times 1. And my factors of 9, I'm not sure. Let's do 9 times 1 because this would give me 27 and this would give me 1. So I'm looking for negative 28. So that'd give me negative 27 minus another 1 is negative 28. Again, if you need to make those just a variable instead of 3 to the x, that might be helpful. Okay, so that tells me that I have 3 times 3 to the x minus 1 equals 0. I'll go ahead and write it out like that. And then 3 to the x minus 9 equals 0. And then let's solve these. So this one is 3 times 3 to the x equals 1. Which means 3 to the x equals 1/3. So then I have to ask myself, well, 3 to what power gives me 1/3? That would be negative 1. If x were a negative 1, 3 to the negative 1 power is 1/3. So same thing here. This one is 3 to the x equals a 9. So then 3 to what power equals 9? 3 to the second power equals 9. Okay, then take those and let's bring them back up and make sure it's going to work out. Since there's no logs in this problem at all, that's fine. So these two answers are good to go. So go back to this problem. When you get to it in your homework assignment, come back to number 8 in this lesson and kind of go back through it. If I were you, I would just write this down so then you don't have to go back to the video to look it up. If it's on your paper, then you can always go back and reference it whenever you need to. Okay.